Okay, today we're going to go over 9-4. We're going to look at these examples and also review expanding and condensing properties. But before we start, let's talk about the word common log. So here you can see there is no base, and the base actually is base 10. So we have that this is, so let's look at a couple examples. We have log base 2 of 8. We have log base 10 of 3, and we have log base e of 5. As you can see here, this has a base 10 and this has a base e. The thing is that in the real world, log base 10 is used quite often. It's very common. So since this is so common, we get tired of writing base 10 all the time. So we just end up dropping the 10. So if you see something without a base, it's implied that the base is 10. And so we call this a common log because base 10 is so commonly used. E is the natural number. You'll learn more about that E further on in the unit. But log base E is also a very common log. So we get tired of writing the E all the time. So we have to use a different notation. We use ln for the natural log of 5, and then we don't have to have the e. So you can see that this one really is base 10. So when there is no base, it's implied it's base 10. And when you have an ln, that's implied it is base e. So this is log base 2 of 8, common log of 3, natural log of 5 is how you read that. So let's go ahead and go to the next slide. So let's review a little bit about expanding and condensing properties. These particular properties basically say that if you have a multiplication, you're allowed to separate it into 2 logs as an addition. If you have a division, you're allowed to separate it as 2 logs as a subtraction. And if you have an exponent, you're allowed to bring this exponent out front and multiply it to the log. You can also go in the reverse direction. If you have a subtraction and the bases are the same, you can bring it back as a division problem. And likewise, if you have an addition of 2 logs that have the same base, you can bring this back and condense it down to 1 log as long as you bring the of parts back together as a multiplication. So these properties you actually should have learned in 9-3, but let's just review them a little bit. Okay, so let's look at example 1. Let's look at if you had log base 3 of 5x. If for some reason you wanted to, you could rewrite that and expand it as log base 3 of 5 plus, because this is multiplication, so you could rewrite it as plus log base 3 of x. And that's what property 1 is basically saying. Let's try property 1 again. If you had log base 4 of x plus log base 4 of x plus 3, you could condense this from 2 logs down to 1 log. So you can go from the right-hand side and condense it back to the other side. So we can write this as 1 log, but you can only do this if the bases are the same, and if it's addition, then you bring the of parts back together again as multiplication. And of course they probably would actually multiply this out, so you might see this as your final answer. Log base 4 of x squared plus 3x. And because all of that is the of part, we need to put that in parentheses. And let's go over an example 3, or problem number 3. Let's go over property 2. If you had a log and you had a division, the property says you're allowed to rewrite it as a subtraction of those 2 logs. And let's go over property 3. Property 3 says if you have an exponent, such as 3 to the a power, you're allowed to bring the exponent out front and have it multiplied to the log. And this is really the property that we need to review for this particular lesson that we're going to do today, because we need this in the coming up. So let's try property 3 again. If you have log, say base 7 of 3 to the x minus 2, you're allowed, according to property number 3, you're allowed to bring the exponent out front. So that is equivalent to, and since all of this was the exponent, you have to put that in parentheses. And that's how property 3 works. So that's just a quick little expanding and condensing properties. We really wanted to talk about property number 3 because that's the one we're going to need in the next coming up. So now let's look at how to solve this problem here. And again, there are many different ways to solve this problem. I'm going to go ahead and solve it the way 9-4 in your textbook solves it. And if you go back to 9-1, here we have an exponential equation. And remember, it's exponential because the variable's up in the exponent. And in 9-1, we tried to get the bases to be the same. And if you can do that, it's so much easier to solve. Unfortunately, there's no way we're going to get these to be both base 2 or both base 3, etc. So we're going to have to revert to using logs to solve this problem. And again, there are multiple ways of doing this. So we're going to do what's called taking the common log of both sides. So we're going to take base 10 log to both sides. And again, that's called common log. So we're going to take the common log of both sides. Right? It says it's equal. So basically all we did is, remember, this is really base 10. So we took the common log to the left-hand side, and as long as we take the common log to the right-hand side, we're okay. The reason why we did that is because the whole purpose therefore is then we can take and use the expand condense properties, which says, property 3 says, if you have an exponent, you're allowed to bring that out front. So we're using property number 3. And again, here we're also using property number 3 that says we can bring that out front. And since all of that was the exponent, we have to put that in parentheses. And now we just simply have to solve this equation. So from here, if we wanted to, since we could use our calculator, log base 10 of 7, use your calculator to get a decimal number. Since this is multiplication, we can undo that by dividing out to both sides, because anything divided by itself is 1. And since we divided to one side, we have to divide to the other side. And you can see the reason why I did that is because that divides out to be, oops, no it doesn't, erase, erase. See my mistake? This is log base 10 of 5, and I divided by common log of 7, and I did not write common log of 7. There we go. Here you have, you're dividing by the same thing, so that's just 1. So that's just going to leave you y minus 2. And then over here, we're going to actually take our calculator now, and we are going to do this on our calculator. So now you're going to actually use your calculator. And when you do that, you should get this decimal. So if you want to put it on pause, grab your calculator, do this with me. And I'm going to go all the way out to maybe the 4th or 5th. I'm going to go out to the 5th decimal. And then those are y's. So remember, this is just the coefficient of that y. Now we have an equation that has linear, that we're just going to get, remember, get all the y's on one side. So since this is 1y, I'm going to subtract 1y. and that's just going to leave me -2. And when you actually do this, maybe using a calculator or not, if it's not necessary. And I'm just going to go out to the 4th decimal place, and remember those are y's. So now we got all the y's on one side and the plain old numbers on the other side. So now we can finish using our algebra skills by dividing out the coefficient. And when you get your calculator, that's approximately, because we've been doing some rounding, so it's not equal, it's just approximate. That's what that symbol means. And I rounded to the 4th decimal place, and I'm assuming you guys know how to use correct rounding skills. Okay, so let's take the exact same problem, but let's do it with more accuracy. So here we rounded really early on in the problem. So we're not going to round until the very end. So we're not going to use our calculator until the very end. And it's pretty much the same, but you're going to see it gets a little bit more complicated. But it's definitely the more accurate way of doing it. So we want to really look at accuracy. So we're going to start off the same. Since we can't get the bases to be the same, we're going to use common logs, and we're going to take the log of both sides. Just like we did before. And again, the reason for taking the common log of both sides is that we can use that condensing property that says we can bring the exponent out front. Y times the common log of 5. And here's what we're going to do. So this is the exponent, so that needs to have parentheses around it because that was the exponent. Here's where it's going to be a little bit different than what we did over here. We're actually going to distribute this log expression. So when we distribute that, that's going to give us y times the common log of 7 minus 2 times the common log of 7. And now notice we have y's on both sides of our equation. So we want to get all the y's on one side. So we want to subtract that out. And whatever you do to one side, you got to do to the other side. And of course, when you have opposites, that just gives you 0. So that's just going to leave you minus 2 times the common log of 7. And you would think you could just subtract 5 and 7 and say 2. You can't. So we're just going to write this expression. And here's what we're going to do now. We are going to, since these both have a y in those terms, so each of these terms, this term here has a y in it, and this term here has a y in it. So we're going to factor out that y. Remember your factoring skills. So we're going to factor out that y, and that's going to leave us common log of 5 minus the common log of 7. And then, of course, this side, we're just rewriting this side. So once again, since these both have y's, we factored out the y, and so now we have y times something, so we can get rid of this by dividing out that something. Because anything divided by itself is always 1. So this is just going to become 1, which just leaves us 1y. And since we divided this side, we must also do on to the other side. Common log 5 minus the common log of 7. So since we divided to this side, we have to divide this side. So here's our final answer. And now is when we're going to go grab our calculator. So this is the expression that represents the answer. Right? So now we're going to grab our calculator. And if you grab your calculator, you're actually going to get, so if you do this on your calculator and you do it correctly, you got to make sure you hit division and put a parentheses in there. Otherwise, you're going to get a completely different answer. You're going to get 11.5665. And of course, I use my correct rounding skills for that last decimal place. But you can see the answer is just a little bit different. And you may say, well, what's the big deal? Well, you know, if it's just a matter of seeing if you understand the process of how to solve logs, but if you're actually working in a experiment, scientific labs and working with equations and whatnot for accuracy, then you can see this actually is a big deal. So that little bit of difference really can make a big difference. So this is really the way you should be doing it, because this is the more accurate way of doing it. A little bit more complicated, but you need to practice it. Okay, let's go through this next example. So again, if I could get the bases to be the same, like in 9-1, it would be so much easier to do this problem. But we're unable to get the bases to be the same, so we're going to take the common logs of both sides. So we're going to take the common log of the left side and the common log of the right side. And the reason why we took the common log of both sides is we can use that property number 3 of expanding and condensing that says if you have an exponent, you're allowed to bring it out front. And we're just going to recopy this side. And since this is multiplication, we're going to go ahead and divide out common log of 11 to both sides. And of course, anything divided by itself is always 1, so that just leaves you x squared equals the common log of 25.4 divided by the common log of 11. So now our goal is to get it just to be x instead of x squared. So what do you think we should do to get that just to be x? Right, since we're squaring it, we're going to do the inverse. We're going to take the square root, because squaring and square rooting undo each other. And whatever you do to one side, you have to do the other side. And because we took and undid a variable being squared, so since we undid a variable to an even exponent, we have to remember the plus and minus. Right? Even anytime you have a variable and you're undoing it, if this is an even exponent and you're undoing it, you got to have that plus and minus. So this is going to give us just x equals, and then we're going to grab our calculator and do this all at once. You've got to make sure that you're using calculator correctly. So you might want to pause this video, grab your calculator, actually do this on your calculator and see if you get the same answer as me. So we're going to put approximately, because I'm rounding, and you should be getting plus and minus 1.1615-ish. I use correct rounding skills right there at the 4th decimal place. Okay, so let's take this problem and do it a different way this time, because like I had said before, there are many ways in which you can do these problems. You don't have to take the common log of both sides to solve this problem. There are many different ways, and I'm going to show you another way. So one way to do this is to rewrite this in exponential notation. So let's review a little bit about exponents and logs. Remember back in the beginning of the unit, you'd have like 2 cubed equals 8. And you were taught that you could rewrite this as log base 2 of 8 equals 3. So here we took something that was written in exponential form and rewrote it in its equivalent log form. So since it's base 2, it's base 2 of 8 equals 3. So we're going to do the same thing over here. So we have that the base is 11. So we're going to just rewrite this equation as a log. We're going to say log base 11 of 25.4 equals x squared. Right? So go back how to rewrite things from exponential to logs if you're having a hard time with that. So as you can see, we're ready to go ahead and undo x being squared by taking the square root of both sides. So we're going to undo the x squared, and because we're undoing an even power, we got to have that plus and minus. Now you can see it comes out a little bit different. I don't know if you noticed the difference between this side and the other side. The problem with this particular problem now is that we do not have, at least most calculators, some newer calculators do, but I don't have a base 11 key on my calculator. I only have base 10 and base E. So we have to do what is called a change of base formula. And I'm going to go over the change of base formula further down in this video. But basically, the change of base formula says that you can change the base to anything you want. And I want to change it to base 10 because my calculator has a base 10 key on it. So it says log base 10 of 25.4 is divided by log base 10 of 11. And notice you have the same answer that you have here. So of course, when you use your calculator, you're going to end up getting the same answer. So to emphasize, right here it was a little bit different, and I don't have a base 11 key. So basically what we had to do is use this formula that is called the change of base formula. And again, we're going to learn that change of base formula towards the end of this video. And you might want to go back and rewatch this, and it'll make a lot of sense. So just wanted to point out that you don't necessarily have to take the common logs. There are other ways to solve some of these problems. Okay, let's go ahead and solve this using the common log way. Again, if I could get the bases to be the same, certainly that would be the fastest and quickest way to solve this inequality. But since we can't, then we're going to go ahead and use the technique of taking the common log to both sides. And from there, we can use the expand condense property. It's property number 3, where you actually can take the exponent and bring it out front as a multiplication to that log. That's what property 3 shows you. And since a minus 1 is all of the exponent, got to put that in parentheses. Don't forget this is an inequality. So here we go again. We are going to do it the more accurate way. So we are going to wait and use our calculator at the very end. So we're going to distribute that log base 10 of 4. So it's going to give me a common log of 4. And then we have to also distribute it here. So it gives me minus common log of 4. And that is less than or equal to, and then we're just going to recopy this side. So remember in algebra, we have a's on both sides. We want to get all our a's on one side, so we're going to subtract. And when you add opposites, that gives you 0, so that drops out and leaves you just negative 1 times the common log of 4, which is less than or equal to. And you really can't, gosh, you probably think you can just make that a 1, huh? But you can't. So that gives me a times the common log of 3, and it's subtracted from a times the common log of 4. And because both of these terms have an a in common, we're going to factor out that a from both of those terms. So we're just going to recopy this side, and we're going to factor out an a from both of those terms. And now that we have a is being multiplied to this wild expression, we can then divide it out because anything divided by itself is always just 1. Anything divided by itself, so this just leaves us 1a on this side, or just a. And of course, if I divide this side by common log of 3 minus common log of 4, then I have to do the same thing to the other side. So my final answer is this. And then we're going to grab our calculator. So again, you may want to pause and get your calculator ready. You might want to try it before I do it and see if you're punching it in correctly. Now, you've got to hit negative times log 4, and then you hit divide, and then you've got to hit a parentheses in there. And people can have issues. They can get a lot of wrong answers because they're not seeing their calculators putting extra parentheses and whatnot in there. So this is your answer as an expression. And then when you actually use your calculator, you should get, and I'm going to go ahead and move this around and say a is greater than or equal to. So a is greater than or equal to, and you should be getting 4.8188, and I use correct rounding skills. So any number greater than or equal to 4.8188 should make that equation true. That's your answer. So I bet if you're not getting this answer, I bet you're using your calculator incorrectly, and you might need to get some help from your teacher on how to use your calculator correctly. Okay, let's look at the change of base formula. So that's what I was talking to you about earlier, saying we were going to talk about this formula later on in this video. So the change of base formula allows you to write equivalent logarithmic expressions that have different bases. So you can change the base from whatever base a to any base you want, as long as you put the n on top and the a in the bottom. And as you can see over here, I've got a picture of a scientific calculator, and notice on this particular calculator it only has a common log key, which is a base 10 key, and it only has a natural log, which is base e key. So there are other calculators out there, as technology gets better and better, that actually allow you to type in whatever base you want, and that's pretty cool. But some of the older calculators, they don't have, they only have common logs and natural logs, and those that do, basically they has been programmed in to do the common log for you instead of you having to do it. So I guess it's kind of a cheating way, huh? Okay, so let's continue. So let's see how this formula works. Okay, so this formula basically says that if you want to change the base, you can change it to whatever you want. So you could say, you know what, I want to change it to base 3. And you can do that as long as you rewrite it as a division problem. Now, do not get this confused with the expanding and condensing property 3. Don't get those mixed up, or with properties 1 or 2. So 7 is going to go in the numerator and 8 goes in the denominator. So notice we changed the base from base 8 to base 3. And that's basically what this formula is saying you can do, is you can change the base. So if we wanted to, we could have said, nah, I don't want to change it to base 3. I want to change it to base 5. As long as you follow the formula, and the 7 goes in the numerator as the of part, and the 8, which was the base, becomes the of part in the denominator. But it would probably be smarter if I have a calculator. Maybe I want to change it to base 10 instead. And of course, I don't have to write 10 there. If it's a 10 and I don't write it, right? Remember, it implies it's a 10. So here you have it expressed as common logs. So here I changed the base to base 10. Or if I wanted to, I can do natural logs. It doesn't matter which way you do it. So that's the point. The point is that you can change the base to base 10, base E, base 5, base 3. You can change this base to whatever you want by using the change of base appropriately. However, if we have a calculator, most calculators only do base 10 and base E. So if we were going to do this one using the common log base 10 and we were going to change this to base 10, then we would say log base 10 of 4 divided by log base 10 of 3. Remember, I didn't write the base 10 because that's what it means. A common error that students often do is they'll put the 3 in the numerator and the 4 in the denominator. Do you see how they mixed it up and put the 3 in the numerator and the 4 in the denominator? And that is wrong. So be careful and make sure that the 4 goes in the numerator and the 3 goes down in the denominator. If we wanted to rechange this base, we could rewrite this base as common log base, common log of 2, as long as we divide it by the common log of 9. Or we could have used natural log of 2 divided by natural log of 9. Or we could have picked any base we want. We could have picked base 7 if we wanted to. That's what the change of base formula says you're allowed to do, and that's how you use the formula. Okay, we're almost done. So in 9-4, they want to make sure that you know how to use the change of base formula. And one of the problems might ask you to express each of the logarithms using common logs. And so you need to know what the word common log means. So basically, they want you to change this from base 7 to base 10. That's what they're saying by common logs. And then, of course, they want you to use your calculator to approximate the answer. So we're going to change it to base 10 by using the change of base formula that we just talked about. And that is it. And then you grab your calculator. And when you grab your calculator, you should get approximately 0.8271. They wanted you to round to the 4 decimal places and use correct rounding skills. And for this last example, again, they want you to change it to a common log, and that means base 10. So common log, remember, means base 10. And so log base 10 of 6 divided by log base 10 of 3. And grab our calculators, and that should give you about 1.6309. Okay, I hope this video helped.